Hey guys, Tomatho here. Can you solve this question without using the logarithm sign? Well, here is the problem. Can you figure out the value of n in this equation? As usual, here are some hints. Can you figure out As usual, here are some hints to solve this question. The hints will be progressive and the later hints are closer to the actual answer. Feel free to pause at any time if you found inspiration from it. First, look closely. If we have a non-zero number x, what is the value of x to the power of 0? Next, if we have an arbitrary number x, what is the value of 1 raised to the power of x? And how about the value of negative 1 raised to the power of x? How can we solve this question? How does this hint help? As I mentioned, this question do not require logarithm. So, to solve for n, we have to consider several things. A non-zero number that is raised to the power of 0 will always give value 1. To briefly show, it's true since a to the power of 0 is equals to a to the power of 1 minus 1, which equals to a divided by a, and this is equals to 1 if a is not 0. So, from the original equation, we can deduce that n squared minus 13n plus 42 is equals to 0. When it's factorized, we have n minus 6 times n minus 7 equals to 0. And this gives n equals to 6 or n equals to 7. So, as we mentioned here before, a to the power of 0 is equals to 1 if a is not 0. And if we plug in the value of n equals 6 or 7, n squared minus 7n plus 11 is not 0. So these two answers are valid. Next, 1 raised to the power of any finite number will always give value 1. This is definitely true since any form of multiplications, divisions, or exponents operation with all of the operands are 1, it will always give output 1. So, from the original equation, n squared minus 7n plus 11 is equals to 1. And simplifying it, we have n squared minus 7n plus 10 equals to 0. Similarly, we factorize them and we have n minus 2 times n minus 5 equals to 0. And this gives n equals 2 or n equals 5. Lastly, minus 1 raised to the power of an even integer will always give value 1. To briefly show, we can write the even number as 2m. So, minus 1 raised to the power of 2m is equals to minus 1 squared to the power of m. And this gives 1 to the power of m, which equals to 1. So, from the original equation, we can conclude that n squared minus 7n plus 11 equals to negative 1. Simplifying it, we have this, and similarly, factorizing it, we have n minus 3 times n minus 4 equals to 0. So this gives n equals 3 or n equals 4. Lastly, to validate that n equals 3 and n equals 4 is valid, we must check if n squared minus 13n plus 42 is even. So when n equals 3, n squared minus 13n plus 42 is equals to 12, and this is even. Similarly, when n equals 4, the value of n squared minus 13n plus 42 is equals to 6, and this is even as well. Thus, we can conclude that n equals 3 and n equals 4 are a valid solution. So at last, we get all of our possible values of n. In total, there are 6 possible values of n, which are 2, 3, 4, 5, 6, 7. What a cool answer! The solutions happen to be 6 successive numbers, from 2 until 7. So yeah, that's all about this question. Do you manage to solve it? Let me know in the comment section below. Thank you for watching. Give a thumbs up if you like this video and subscribe to my channel if you would like to see more interesting math videos.